Good morning, afternoon. What time of the day is it? I've lost track. I'm Jordanna.
And I'm Ellis.
And we're here to talk to you about protecting your sensitive data.
Great.
So a few years ago, Scott and I launched here Cloud Data Loss Prevention. And we aim to bring you a core set of tools to help you to protect and classify your sensitive data so that you could reduce your data's risk through its life cycle. Today, we're excited to share with you that we're expanding beyond DLP to sensitive data protection. While important, data loss prevention is really just one use case that we see our customers apply our tools to. While this new expansion will bring you more tools and new features, Cloud Data Loss Prevention and the DLP API aren't going anywhere. We're not going to have you have to migrate or redo any code or redo any integrations. You'll find that all in our new home here. We'll also continue powering Workspace DLP and DLP Chrome and Beyond Core Enterprise. So those services will continue benefiting from all of our investments in improved discoverability and improved detection models, while we now invest more in other areas. One of the two key new components that we're investing in is what we call the discovery service, which we're going to talk a little bit about next. So discovery is a service that automatically generates sensitive data profiles of all of your data in an organization. It helps you determine where your sensitive data is so that you can help protect it and make sure that you're doing all the things you want to do. There's no jobs, there's no code. Some users would write inspect jobs and manually try to build their own discovery service. So this takes care of that for you with automatic generation and orchestration of these profiles. It currently supports BigQuery and BigLake, and will be expanding to Cloud SQL before the end of the year. Once discovery has been enabled in your organization, there's a lot of different ways in which you can use the produced data-sensitive profiles. From the console, the profile gives you a starting point to just see general information about the data sensitivity and data risk of all of your data, and tools to investigate who has been using those data, how the data is being used, and what you're doing right now to protect it. There's also a new level of granular reporting. Data profiles go all the way to the column level. And so in this example, I have a column that's actually been classified as a credit card number. So the profile will tell you, hey, we think this is a credit card number. We think this is a social security number. We think this is some sort of medical identifier. We'll go all the way into the column and tell you whether you've done anything to protect it. Is it public? Does it have proper policy tags on it? We'll also tell you things like, is this structured or unstructured, which might indicate more risk of more data information hiding in there. Of course, we have hundreds of detectors that this works with, and you can also customize what data you think is sensitive, because sometimes your data needs and what you consider sensitive aren't the common ones like credit card numbers. You can also include all of the normal custom detectors that you've known that we've had with DLP API. Now, the easiest way to turn this on is to just turn it on for your whole org. One click, turn it on, and go. But we know that most companies want to start slow and try sampling in a smaller group, and so you can choose to select a folder or a project or projects and start profiling only data within those small areas before you go and turn it on for the entire organization. You can also choose when tables are reprofiled. So you might choose that, hey, I trust where the data comes from this. I only want to reprofile this if a schema changes. But I have another table where the data's coming in from a third party I don't really trust. I don't know how good of a job they're validating that they're not sending me data they shouldn't be. And so those tables you could choose to reprofile every week, every day, whenever data changes at whatever cadence you'd like. You also have options to control when to do backfills. So we obviously have a lot of data sitting in here already, and you might not have the budget to profile everything all at once. And so you can choose to set backfill timestamps to say only start profiling tables from the last quarter or 3 months, and then slowly move that clock back as you have budget to profile older data. You can also set things like minimum row count, which helps you not profile data too fast. So employee creates a new table, they haven't really populated it with enough data signals for us to get a good profile of, you can ask us to wait until it has enough data before we profile it. Of course, all of these controls can be customized and configured for different data sets, projects, folders, tables. You can set up regular expression patterns and set up the combination of rules and patterns to just best suit your needs. You can even set up so that, say you disable all profiling on your test-generated projects, but maybe turn on more frequent profiling for a data set that is, say, a public folder or your payroll data. We have two modes of billing for this. There's consumption billing and subscriptions. There's also a free tool to help you pick which one would best suit your company's size and needs. Once you've enabled discovery, there's a lot of different connections where we surface data profiles to help you with your operations. We have free out-of-the-box reporting using Looker Studio, which gives a great bird's eye view of your organization's sensitive data, and it's really useful for auditing and reporting. We also can enrich your cloud security and SecOps by sending these profiles into Chronicle and Security Command Center. So having this data alongside your threats and vulnerabilities lets you prioritize your security work based on the sensitivity of the impacted data. Data ops teams can also leverage these signals from right within Dataplex. So if they're doing a search or an audit across your entire organization and they're combining and searching with business tags, they can also combine and search with the data profiles in this data sensitivity. Lastly, since discovery runs continuously, you can build custom alerting or event-driven orchestration using Cloud PubSub. This could be useful for automating policy changes or automating remediation, or building custom alerting to alert you, say, when a table goes from low risk to high risk and you had thought it had no data of concern. Scott's actually going to now demo for you that now that we've turned this on for an organization, how you can also take other actions with the data profiles.
Great, thanks, Jordanna. Okay, here, we're going to switch over to the demo. And we're going to walk through how you can leverage the discovery and the results to really take action to better protect your data. And for this demo, we're going to introduce Angie, who's a data compliance officer for a large financial firm. And Angie has a problem, what they call really an ocean of data, and it's just full of unknowns. And the way they look at it is there's about 5% of the data that they really understand well and they know is sensitive. There's about 5% they know isn't sensitive, and then about 90% they just don't even know about. Sometimes they don't even know it exists, and a lot of times they just don't have control or kind of visibility into what's going on there. And this is what we want to try to help Angie solve today. So the first question is, really, how can I get a view across of the data across my organization, even the data that I don't know about? The data maybe that's sitting in those projects that are in my org, but no one's self-reporting it, they're not showing up in any dashboards at the moment. How can I get that kind of wide visibility? So we're going to use the discovery tool that Jordanna mentioned, and we're going to go in and look at a live dashboard. This is on our test organization for Angie. And this is an example of that bird's eye view. We've been running it for a little while. We can see that aggregate view of all the data that we've profiled. It's a very highly sensitive org. Now at the very bottom here, we can see a daily activity chart. Every day, the summary of the data that we found and the risk profile of that data. And you can see here that there's been some pretty big spikes, even recently, of a lot of highly sensitive data that came into the organization. And again, this just gives a little bit of that heartbeat of the organization. Someone goes in and creates a project, creates maybe some tables in that project. This will just pick them up, profile them, and show up on the report here. Now, from this bird's eye view, you might want to drill down and look at something like, in this case, what region, what geographic region is that data in? So we can slice it and drill down by cloud region or geographic region here. Or drill down and look all the way down again to a table or an individual column. So in this case, we've drilled down to a particular area where we have data coming in from a partner, that we use that data, but it looks like we found some very highly sensitive data that was unexpected. So we're going to go here from the dashboard, and we're going to go into the Cloud Console view of that table. Now what we see here is the table profile And down below, we see the individual column profile of every column in that table. And we can see here that we have one column here that's payment card information. It's highly unique credit card numbers. So we see that ranking there that it's highly unique. And what that means is that it's likely that every single value in that row is a unique credit card number, as opposed to a low unique score would be something like the same card repeated over and over and over again. So again, this is all information to try to help us understand the types of data and the size and shape of that data. So the first thing we really want to look at is who can access this data and who has been accessing this data. So from here, we can see the detailed IAM permissions, and we can see for our organization that the entire data engineering team has access to this table. So that's a concern. Everyone on the data engineering team can access this table. They have an access grant at the data set level or at the table level. Next, we're going to jump into cloud logging. And what we're going to do here is we're going to look, as you see in this report, we're going to pull a report of all the accesses over the last 30 days on this table. And as this loads in, we see some accesses in the past week. And then we see some accesses up here. We're just going to look at this first one here. A couple weeks ago, one of our data engineers went in and queried this table. And from the access logs, we can see who the actor was. It was someone named Scott. It wasn't me, but it was someone else at the company named Scott. And we can get down and even see all of the fields that they queried. So this is a listing of all the fields in that table that were queried. So we know just from this log that about 2 weeks ago, Scott went in and viewed all this data. And we know from the profile that there was highly sensitive data in there. So now we have both answers here, but we have too wide of an access. A lot of people can access this data. And now we have evidence that somebody went in and saw the data that maybe shouldn't have seen it. So really, Angie's discovered this kind of anomaly, a highly sensitive table with people that have accessed it. In this case, we see again that Scott has gone in and accessed those particular fields. And it turns out that Scott has a reason for accessing this table. And so really, the next question is, how can I move to a more least privilege model without creating unnecessary friction? Now in this case, that data engineer needs to run an aggregate database, aggregate dashboard, where they look at the payment types and they aggregate the most popular payment types. So they take that data, they throw it into their BI tool, and they run that. Imagine a pie chart of different payment types with the largest amount being the biggest pie chart. But in doing that, they're really going into that table and doing a select star and pulling all that data down. So we want to allow Scott to still run that query, but we don't want those sensitive fields to be part of that access. So let's go back to this data profile. And to fix this, we're going to use something called BigQuery policy tags. So from here, we're going to go into BigQuery, and we're going to just look at what the table looks like at the moment. So we see here, this is in BigQuery's view. We see the schema, we see those sensitive information fields here. And what we're going to do is we're going to apply a policy tag to the actual fields in that table. Now for this demo, I've created a copy of this table just so we can kind of see the side-by-side comparison. So this is that same table where we've gone in and applied policy tags on the individual fields. So you see the little warning that we see next to those, but the payment type and the transaction amount is still available. So I can run my dashboard report if I was running that count or group by payment type. But let me go ahead and query the table here. And let's say I do a select star, just like that log showed before. We're going to run this query, and you notice I got a result. It came back, no errors were generated, but there's a warning message that said, your data's been masked, and we see if you look at all the fields, a lot of them are reporting null, even though those fields actually have data in them. And what we're doing here is we're creating that balance between granting access to this data engineer that needs to see those certain fields, but restricting access to the highly sensitive fields like contact information and payment card data. So I can still run my analysis as long as I don't need to use those sensitive fields that I don't have access to. Now, the reason that we set that up is we wanted that statement to work. A select star still works. If we jump into the data security policy that we set up, what we're going to see here is that this policy, we've categorized our data into a couple different categories. We'll zoom in here to these financial and PII categories. We can see here that we put a policy on those called nullify. And that's why we're getting back just null results for all of those columns whenever I tag something. So in this case, I tag something credit card number, it rolls up to that financial policy which nullifies it for those users. You can also put in allow deny policy or other types of masking. An allow deny policy would have rejected my query if I included the fields I'm not supposed to see. Again, you can find the right balance for what you need. Great, so we've solved this kind of least privilege problem with minimal friction. We didn't have to go in and make copies of the table and have different access lists and everything. We can apply those policy tags and get that fine-grained access control while still technically sharing that whole data set with the entire data engineering team in this case. So next, let's say we want to be able to detect and mask structured and unstructured data at query time. Now what we just showed was taking that profile, tagging the columns, and applying that mask at query time. But what if we actually wanted to use our engine and inspect the data and mask it as part of our SQL? So for this, we're going to go in and we're going to show what's called a user-defined function in BigQuery, which will actually call our engine live as part of the query. And for this, we're going to use this demo set here. Zoom in a little bit. So we have a very simple query that has 4 rows of data. We're going to run this. And you'll notice that in our test data set, which is sitting right here, rows 1, 2, and 4 are the same value. And what we're doing is we are hunting for email addresses, and we are using our deterministic encryption to tokenize that data. So you'll notice in the results, rows 1, 2, and 4 are getting the same value. Row 3 is a different value. Now, just to kind of emphasize that point and why that's important, let's run that same query, but let's wrap it with an aggregate query. So what we're going to do is we're going to count the email addresses, but we're going to tokenize them first. And what you see here is, as expected, we get one email address, now tokenized, has 3 values, count of 3, and the other one has a count of 1. And the reason we're showing this is when you run tokenized data like this, you can still run joins, you can still run aggregates, but the actual data is hidden through our tokenization. It's obfuscated. And so we can do that at query time and see that masking right here. Now, the full power of our engine also allows you to do this on unstructured data. So if we run a very similar query here, in that first column which says encrypted, what we're seeing is we've actually hunted for the email address inside, and in this case also a phone number, inside of the sentence inside of the cell, and only encrypted that part. So you also have the ability to process it on unstructured data. And this particular method is reversible. So we show that in the third column, we can actually take the encrypted value, put it back in, and with permission, reverse it back to the raw data. So it's a very powerful back and forth engine. You can choose one-way methods or two-way methods, but this kind of shows you that end to end. And what's important here is, let's say that you had a particular table. In this case, let's say we had email and notes in a table, and we wanted to run this on one of our tables and create a copy that we could then share out to others. So in this case, what we're doing is we're running that masking of the email address, masking of the email inside of the note field. But we can actually now materialize this view or this result and then share that table or save it if we needed to send it outside of BigQuery. So again, this is another way you can actually manipulate the data so that when you materialize it, it's now stored at rest in an obfuscated form. And what's really cool about this system here is it can also work on just about any table that BigQuery can access. So here's me running that same query, but on an external table. So this table actually lives in Cloud SQL in a, I think it's a Postgres database. We're running that same query, but you'll notice that I'm actually doing an external table query on the destination, but I'm doing that same select statement with our user-defined function. And again, we get those results out, but this is querying a Cloud SQL database now. So really, anywhere that BigQuery's UDF or user-defined functions can be run, you can now leverage this to manipulate your data, and again, maybe materialize it somewhere else. And it's actually not limited to BigQuery. This is a screenshot of us doing a very similar UDF, calling our same DLP system, but running in Snowflake's SaaS system. So from here, as you can see, we have a very similar encrypted DLP function. And in this case, we've done different manipulations. It's a very flexible system to do partial masking or full encryption, as we see here with the card number. It's revealing, masking everything with the last 4 digits. And on the social security number, it's doing a full encryption. And then we applied it to some data inside of the note field, in this case, again, hunting for certain data types. So we wanted to show that that's really how we can help Angie, in this case, take action, protect the data. And we showed some of the stuff going beyond discovery, that sort of inline masking. And now I'm going to pass it back to Jordanna to go in more depth about some of the stuff you can do beyond discovery. Oh.
Yeah. There we go. So we've shared with you discovery, but as I mentioned, sensitive data protection is meant to cover more than just the discovery service. The Cloud DLP API still lives on, and we still have a lot of other services from within the console. We offer APIs and a native Cloud Console tool to inspect data storage systems, including Google Cloud Storage, BigQuery, and Data Store, and even custom storage systems using our hybrid APIs to investigate and find individual findings. This is really useful when you need really precise details about where exactly all your sensitive data is, for often use cases around de-identifying it. We also have tools to help you measure privacy risk by looking at statistical anomalies and common re-identification metrics. These re-identification metrics help you inform you on the likelihood that someone could reverse engineer who data belongs to or who it identifies. From the console and our APIs, we offer a number of de-identification solutions, which Scott has just demoed a few of. They come in both API form, and we have native support for data sitting in cloud storage. We have many advanced masking techniques across structured and unstructured data, which can be used virtually anywhere, as he showed. Importantly, your data analysts and your researchers can leverage these techniques to tokenize data while keeping referential integrity. So no more saying, well, I need to have the email addresses for, you don't need the email addresses. Please tokenize it. Just don't risk it. And these tools are super easy to use, and they won't interfere with their jobs and their ability to use the data. Our platform and our APIs are super useful in protecting your AI and your machine learning workloads. You can remove sensitive data before ever training on it, or you can use it when customers interact with you, as the data comes in from the customers in the queries, or as you send responses back. Our APIs are fast enough to serve that traffic in real time. Tomorrow morning, there's going to be a talk at 11 on data governance and generative AI that I encourage you all to go to think more about this. Our de-identification platform is also built into the contact center AI. So this lets you choose how and when to transform your customer's sensitive data before it's used in insights and training. It's fully customizable by using a de-identification template so that you can define when and how and what it does. So whether it does full redaction or tokenization or masking or some other technique. So in summary, sensitive data protection enables you to understand your data, manage that data's risk, while still being able to use that data for all of your important workloads. To get started, You can turn on data profiles for free for 20 tables, and some of our consumption APIs also have free tiers. You can also check out Dialogflow, Workspace DLP, or Beyond Core, which are all powered by sensitive data protection.